Hello everyone. Today we will be going to ATAN2 function in Excel. When you have to convert the coordinate into the angle form with respect to certain axis, then ATAN2 function is useful. ATAN2 function automatically gives the value of your result in the quadrant, wherever it is actually fitting. So let us try to understand what ATAN2 function really does. At first, ATAN2 function in Excel, the syntax of ATAN2 function in Excel is ATAN2 x number comma y in the result will be in the radian. So Excel automatically denotes the value in radian. So this, if you type this in Excel, the result will be in the radian. And what it does, what is ATAN2? So ATAN2 is nothing but it arctangent or tan inverse. So let us try to visualize it. Let us suppose we are in this quadrant. Let's suppose this is x-axis, this is minus x-axis. Suppose we have certain point. So let this be point 1 comma 1. So this is positive value. This is, if you go x along x-axis 1 unit and along y-axis 1 unit. So if you join this, so this line will be the line joining from origin. Suppose that it the point A. Okay. So now what does this represent? So if you make ATAN2 x comma y in radian, this is the syntax. So this is the syntax in Excel, ATAN2 x comma y, and this gives the value in radian. This gives the angle in radian. Okay. So the value in radian is given by this function. So in actual, what is it is theta. So this angle theta is tan inverse. What is this? This angle theta, this is perpendicular, this is base. So that will be P by B, or tan inverse. What is P? P is, this is y coordinate, this is x coordinate, right? So y by x. So the angle in radian for this x and y coordinate is tan inverse y by x. So this is the angle made by this line OA with respect to this x-axis containing origin. So always, if this type of angle is there, then this angle is made with the positive x-axis. Okay. So let us try to see some of the values. Now this is in radian. Since you have to convert this radian into degrees, then you can directly go to function degrees ATAN2 x number comma y number. So if you put this, the value will be coming in the degrees form in Excel. So now let us see how this ATAN2 function work in the quadrant. So how you can manage the quadrant in ATAN2 function. I put x coordinate here, y coordinate here. Let us see. So let us put x coordinate 1 and y coordinate 1. Let's suppose B point be this. Let's suppose C is this. Let us suppose D is this. Okay. So I am assuming certain coordinate, and how does this ATAN2 function actually works? I'm trying to visualize you people. Okay. So let us assume this is minus 1 comma 1. This is minus 1 comma minus 1. This is x is positive 1 comma minus 1. So I try to make the coordinate of each of the points here, and if I join this line, okay, so I join all these lines. Okay, so let us see. So x comma 1. So first for A, this is 1 comma 1. For B, this is A. Okay, this is B minus 1 comma 1. This is C minus 1 comma minus 1, and this is D 1 comma minus 1. So I put the coordinate of A, B, C, D here. Okay, so now what it does, if you put ATAN2 function, okay, if you put degrees, what is your syntax? ATAN2 x comma y. Okay, x is this value in Excel comma y. Okay, so degrees ATAN2 x comma y. If you put this syntax, over here, then for this it will show 45 degree. Okay, for B it will show 135 degree. For C it will show minus 135 degree, and for D it is showing minus 45 degree. Okay, so what it is doing, I need to mention it. So for A coordinate, so always remember that ATAN2 in this case is using a syntax. ATAN2 is the tan inverse of x and y number. So that is tan inverse y by x. So x number comma y number. So this is the syntax. Okay, so this is in radian, then you are using degree. Since I have to know the value in degree. Okay, so what is doing? So for this, it is measuring this angle. So this is angle positive, this angle is positive, so it is representing this angle theta. This is in, if the result in positive, then it will measure anti-clockwise angle, counterclockwise angle, anti-clockwise angle. You can see from this figure. Again, you are measuring from this, for this line, it gives this angle 135 degree. This is again positive, so anti-clockwise angle. For this line OC, it is giving you the angle from this side. This is the clockwise angle. So this is giving you minus 135 degree. So this is not from this one. So this is from this minus 135 degree. So this is clockwise angle. This is clockwise angle. And minus 45 is this angle. This is again clockwise angle. So for this case, what you can see is the anti-clockwise, if the angle is positive, then with respect to this positive x-axis, the positive value showing anti-clockwise from this line, origin for this x-axis, positive x-axis line. And if the value is negative, it is giving you clockwise angle. So this is what ATAN2 function in Excel really does. So let's see what will happen if you just make ATAN2 function and just reverse the order. Okay, so this is very interesting as well. Let's see. So if you just reverse the order, okay, I will visualize here. If you reverse the order, so what will be the thing that will happening here if you reverse the order? Okay, so while reversing the order, I will show this is point A, B, C and D. X coordinate is 1, 1, minus 1, 1, minus 1, minus 1 and 1, minus 1. Okay, now if you type degree is equals to degrees ATAN2 y, x. Okay, so if you type this function in Excel, then what will happen? So I just rub this out. So we have this is positive x-axis, negative, this is positive y-axis, this is negative y-axis. So we have point A, we have points A, B, C and suppose D here. So if you join these points, these are our lines. Okay, let's assume these are our lines. So this is your C. So this is minus 1, minus 1, 1, 1, minus 1, 1, 1, minus 1. So this is our x and y values. So let's see here, if we reverse the order of the function ATAN2 y, x, what will happen, right? So let us see. If this means what? The sentence ATAN2 y, x means, right? ATAN, it is tan inverse of x, y. So it is representing tan inverse x by y. Okay. So if you are using x, y, the angle is being from positive x-axis to this one, right? Now, in many a case, like in the case of bearing, you need to measure the angle not from the horizontal axis, not from this axis, maybe from north or south, right? So that is the case. For this, we have to use this type of function. So let's see what will happen if you use tan2 y by x function, tan inverse x, y. Okay, so the angle in this form, theta. So for this, okay, this will be your, this is for theta, this is be perpendicular, this is be base. So then tan inverse, what is this? P by B is tan inverse. P is, this is x, this is B is y. So this is the syntax, right? For this you need to type ATAN2 y, x in Excel, right? So this is the correct order if you want angle from this, right? So if you just type this in Excel and if you just get value, first angle is 45 you got from this, right? So second angle will be minus 45, this will be minus 135 degree and this will be 135 degree. Okay, so you can use these values. Now what actually it is doing, let's see what are the coordinates that it is trying to represent from this value. Let us try to make it. Okay, so I will try to show you these four values. So look, at first tan inverse this by this, x by y, tan inverse x by y, 45 degree. So this is measuring angle from, so the value is positive, the value is positive and it is measuring angle from this line, okay? So this is measuring angle from this origin to positive y-axis and giving you this angle of 45 degree, first case. The second case is the quadrant. So this is negative value. So negative value represents, in this case, anti-clockwise direction. So this is of minus 45 degree. This is counterclockwise direction. And C is this point. This is giving you 135 degree, that is in negative direction. So again, this is giving you anti-clockwise value. And 135 degree is this, and this is giving you angle in the clockwise direction. So what you get from these result is that the positive value gives you clockwise and negative value is giving you anti-clockwise with respect to positive y-axis. With respect to positive y-axis, this is anti-clockwise and this is clockwise. Look, from this axis positive value was giving you anti-clockwise, but for this axis the positive value is giving you clockwise. Okay, and negative value is giving you anti-clockwise. So you can just see the difference here. Okay, you can see the difference. Now from this interference, what you can conclude is, now you can conclude something extra, that in case of bearing, you are measuring the angle from north, not from this horizontal axis, right? So you are measuring from north or south, from this axis. So for correctly handling the function using ATAN2, which quadrant is the bearing, for that you have to use the function ATAN2 y comma x. This is the correct syntax if you are dealing with the survey lines. Okay, you can just see the difference here. So you can see in this case, first for line this, the bearing is 45 degree, and for this minus 45 degree, what is the correct bearing? Is 360 minus 45 degree, then that will be coming out to be bearing of this line with respect to north. And for this total 360 minus this angle, you can get the bearing. And for this 135 degree, it is positive with respect to north, it is clockwise angle, so that is 135. So you can relate here that if the value is negative, you have to add this angle with 360 degree for get bearing. If the value is negative, you need to add 360 degree to get bearing for with respect to north in clockwise direction. And if the value is positive, that is true. So you can see the difference like this. Okay, so this is very simple. So what is the difference between ATAN2 x comma y and ATAN2 y comma x? So after this, you need to understand this. Let's try to make one figure. So the difference between these two, these are the lines. I represent line here for simplicity. Okay, this is A, B, C and D, A, B, C and D. Okay, for angles, for if you are just using x comma y, the angle will be measuring from this axis. If it is positive, that is anti-clockwise. If it is negative, that is clockwise. So this is showing you this value, and this value, if you do not use degree in front, that will be always in radian from minus pi to pi. The angle will be from minus pi to pi. Okay, this will be the angle in radian, right? But if you need the value in degrees, then you need to convert radian into degrees by using the function degrees before this function. Okay, and in this case, if you are measuring from this axis, that is more relevant with the survey lines. This is north axis, north and south axis, right? In this case, the angle will be either positive or negative. Value will be either positive or negative. The positive value is there, it is measuring clockwise angle, and negative value is there, anti-clockwise angle. From which this line. Okay, so for survey purpose, you need to follow these things. However, these two are using A2 function and directly giving that quadrant of each line with respect to certain axis, right? So if you're using this axis, it is giving you quadrant in which these lines are there, actually there. Okay, so if you use this is the quadrant in which they are actually being. Okay, so you can see this axis is changed into this axis, so just the values are changed. So if you rotate this value, if you just rotate this and go this, then the reference line will be this in the case of ATAN2 y comma x. So now after this, I will show you how you can use this in surveying to calculate bearing. Okay, so I will show you the difference to calculate bearing of the line. Okay, so you have to understand this concept to calculate the bearing from latitude and departure. Okay, so let's try to understand in terms of latitude and departure. Then we need to use this quadrant. So let us try to use, if this is in first quadrant, let us see if the length of this line is L, and if you want to get angle from this, then this line length will be L cos theta and this will be L sin theta, right? So you all know that L sin theta is departure and L cos theta is latitude. Okay, so that is representing y and this is representing x coordinate, right? So for a survey line, to know the degree from this function, you need to use first degrees. ATAN2 is your function. Then you need to use syntax y comma x, right? So that will be, you need to use degrees ATAN2. This is y, means latitude comma departure. So this will be our syntax to know the bearing. Okay, to know the bearing. Now the value can be either positive or negative. You all see that the value can be either positive or negative. If the value is positive, then it is measured clockwise angle. If the value is positive, then clockwise. If the value is negative, then it is anti-clockwise. So to know the bearing, if the value is negative, then you need to add 360 degree in this negative value to get the bearing. Okay, so if positive, then that is correct bearing. If negative, then you need to add plus 360 minus that negative value to get bearing. So this is what you need to understand. Let us try to see if the value is negative, how you have to understand this thing. Okay, if the value is positive like this, if the value is positive, it is in first quadrant, then you directly get the bearing. But if the value is negative, let us see what will happen, right? So if this is quadrant, this is minus 1 comma 1, then this will be your line. Then you will be getting the bearing from this vertical axis. This is x minus x, this is y minus y. So the bearing will be coming out to be minus 45 degree. Okay, like this. If this is minus 45 degree, you cannot, sorry, angle will be minus 45 degree. So for that bearing, you need to use this value, isn't it? That will be from the north. So that will be 360 degree minus, or you can use minus 45 degree. You can add 360 degree in this. Okay, so that will be 315 degree. That's it. So you get the bearing 315 degree in this case. Is it okay? In the similar manner, if the value is minus 135 degree, so minus is what? Anti-clockwise from this. So minus 135 degree, right? Then you need to get the bearing, isn't it? So that will be minus 135 degree plus 360 degree. Okay, so you can easily subtract this value and get the true bearing from this value. Is it okay? So this is how you can use ATAN2 function in Excel and use that function in surveying so as to calculate the bearing considering all the quadrants. So in surveying, now if we are using the departure and latitude, so departure is nothing but x and latitude is in the form of y coordinate, right? So this is y coordinate. If we are using ATAN2 function x comma y, let's see. So let us see here. So what ATAN2 does, right? ATAN2 function, this is x, a16 and b16 is y, right? So ATAN2 is doing this. So bearing is coming in with respect to like this, right? So this is the angle. This is the angle from positive x-axis, positive x-axis, positive x-axis, positive x-axis. But for bearing, you need to have the angle from y-axis, right? Y-axis. So you have to type ATAN2 y comma x function. So you can use degrees, then ATAN2 function, and this is y and this is x, right? And so the now the angle is coming with respect to positive y-axis. Now you can see here. So what is the difference, right? What is the difference? You can clearly see the difference between these values. So you can see here a difference if you are just using ATAN2 and x comma y, right? So this is your positive x-axis, this is y-axis, and this is negative, and this is negative y-axis, and this is negative x. So for this, if you are using departure this value and using this value, then the angle is 25 degree is measuring from this positive x-axis, right? This is 25.49 degree. However, ladies and gentlemen, in the same thing, if you are using ATAN2 y comma x, then the value is coming from this, from positive y-axis, right? Positive y-axis. So this is the angle of 64.50 degree, ladies and gentlemen. So as the bearing is required from positive, from this north or south, right? From bearing is always measured from north. So the bearing, for the calculation of bearing, you need to use ATAN2 y comma x. This is very easy, right? For the second set of values, the bearing, if you are using ATAN2 x comma y, 131 degree, right? So this is 131 degree. This is like this, 131 degree. It is measuring anti-clockwise from this positive x-axis, 131 degree, right? But however, if you are measuring this y comma x, ATAN2 y comma x, then it will be like this bearing, right? So the angle will be minus 41 degree, isn't it? So you have to make clear distinguish between these things. Again, for setup 3, minus 14 degree in this value, minus 14 degree, so that will be like this. This is measuring clockwise, minus 14 degree for this value. The same 104 degree will be coming from this side, right? This is clockwise 104 degree. So ladies and gentlemen, you can say that if the value is clockwise from this, the positive value is the correct bearing. This is the correct bearing in this case. However, if the value is negative like this, minus 41 for this, then you need to do minus 41 plus 360 degree. Then this value will be the correct bearing. Now to calculate the bearing, you can use if function and convert the bearing like this. If, then you need to go for logical test, right? This value is positive, then its value is positive, then you need to, the correct bearing is this one, right? The correct bearing is this value, right? Otherwise, the correct, if the value is negative, value false, then this value plus you need to add 360 degree like this, right? So if you do this, you can get the bearing with respect to north.